So every pi system is concerned with taking data from items and things and measurements that are important to you and getting them to you and the people around you. So to start this off, let's say you own things out there, like you own a building or you rent a building, and you own equipment like you have tanks, or you own equipment like stuff that runs and takes electricity, like a pump or something. Or any collection of these things. They're things that you own. And there's things about them that we want to know. So, over here, there are people. This is you and your peers. And they want to know stuff. They want to know things like to see a chart and to be able to do some analysis on maybe the running time of the pump, or what's the RPM of it. Or maybe somebody wants to see a spreadsheet report of the production data for that tank. Or maybe somebody wants to see what the temperature has been like in that building and get a notification if it goes too high. So these are things we want to be able to deliver about the stuff that we own or the stuff that we're concerned about. And how do we get those things connected to each other? Well, there's one video on the servers and the hardware that's in between here that's actually delivering this to this in the Pi system. But what I'm going to talk about in this video is how do we organize this in the Pi system? Like, how do we kind of organize the database that represents this data and makes it available to the end users? Okay, so that's going to be in 3 parts. There's Pi assets, there's Pi asset attributes, and there's Pi tags. And those 3 things will be the building blocks for how we organize data in the Pi system. So we're going to start off with Pi assets. Or, perhaps to be a little bit more precise, Pi AF assets. So this is something from the asset framework, that's AF. And the first step in representing this data that we can use over there is to take the items that we have and represent them in our database. And that's what we do in the Pi AF database. We actually take these concrete items and we just give them digital representations. We just give it a little spot in the database for the building, and you could say we represent it with a little block. Sometimes this is how it appears in OSIsoft products. And maybe we have a tank, and we represent that by a little block, and this just represents in our database tank. And maybe we have one for our pump, and it has a little element as well. And then when one of our users logs on to one of the OSIsoft products, they're able to see these different spots in the database, and that represents a building. It's pretty straightforward, and you've probably seen a lot of tree structures that are organized like this. Often a building will then have things inside of it, or like maybe each floor. And then each floor will have a set of rooms on it. And we can organize the whole hierarchy of how the different pieces of the building fit together. And then the users can look at that tree and browse it. And all they need to know is how the building is organized. They don't need to know anything particularly about the depth of the Pi system. Okay, so that's Pi AF assets. It's a way of defining an item, a thing, that's either a concrete thing or maybe some organization, like the maintenance organization could be an asset that we own. Sometimes this is also called an element, but we're going to use the word asset for now. But if you hear element, we're also referring to this. So the next step in actually delivering data to these guys so that they can use it is that we need to have something to graph or something to chart. Right now, I can't just chart pump, and I can't just chart tank. That's an item. It's not a stream of data. So the next thing is we need to have some way of describing this asset. So this tank has things about it that are of interest, and we would call those all attributes. Attributes. Pi AF attributes. Now, an attribute is something that describes an asset. So, for example, for the building, maybe one thing we would have is the temperature, because the temperature is very important in a building like that. Another attribute of a building or a room maybe would be the square footage. So how big is the building? How big is the floor plan? For a tank, we might be interested in something like, what's the capacity? So what's the capacity of the tank? We might also be interested in, like, what's the height of the tank? Like, how full is the tank right now? That'd be something of interest. For something like a pump, maybe we're interested in what's the rotations per minute of the pump right now. We might be interested in the install date. So when was the last time we could draw? I'm going to draw a little wrench here for the last time that we did some maintenance on it. So when was the calendar date that we last did maintenance on this pump? So these are all attributes that describe something important about our asset. That's what an attribute is. It describes something important about our asset. And an attribute is something that we could actually put into a spreadsheet or put into a graph or, put into an email. They're all things like that. That's what a pi attribute is. That's what a pi asset is. And this can actually be represented in the pi system. These are, when you go in and you find an AF structure, an asset, you can find an attribute. And they have a variety of different types that we could use. We can have ones that refer to just a constant value. So something like the capacity. That's just a constant value for this tank. It's set and it never changes. It's just a constant value. So we can have constants. We could also have something that's a formula. So it's the result of a calculation. And the result of the calculation is the attribute. So perhaps the height here is the result of a calculation. It's the result, or not the height, but the volume. If we also had an attribute that was the volume, something like the volume, well, the volume is going to be the height multiplied by the surface, the circle area on top. So we get a cylindrical volume. Well, that volume is going to be the result of a formula. Also, we can have data references, so table lookups. And this is where we might access some other database. So say there was a maintenance database and we wanted to access when it was last maintained. We can pull this data in from a outside database, and then it's a table lookup versus a formula that's actually calculated within the pi system. And then lastly, and perhaps most notably for the pi system, is something called a pi point. Dun, 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 dun. And a pi point is the super duper storage point for the pi system that stores real-time data, also known as a pi tag. Okay, which I'll talk about in just one moment. So a pi point / pi tag, they're the same thing. So pi attributes can be a big variety of things, and one of them in particular is this. It's a pi tag, which is some way of storing real-time data. It's a way of storing data in real time. So pi tags are always usually always going to be graphable. It's like you could take a pi tag and you could graph it against time somehow. And it might be of different types of values. Maybe there's some that are like digital state sets against time. There's some that are just slowly ramping up against time. But they're all against time. That's the superpower of pi tags, and it really is what makes a lot of the pi system extremely powerful. Pi tags that can be referenced against time. Now, pi tags, because they're such a core piece of the pi system, and really they are what is classically the pi system was built on for decades, was pi tags. And now we have attributes to be able to bring in all sorts of other data that really isn't time-based. Constants don't change over time, so just having pi tags was limited. But now with pi AF attributes, we can include formulas, constants, table lookups, things like that. And we can bring in data changing against time right here with a pi tag. Now, pi tags can come in different data types. They can come in, let's see here. We can just have a decimal place. We also might call this a floating point number. They can be integers. They can be Boolean. We can have something called a blob, a binary large object. There's different levels of floating point and integers. They can be string values, and they can be digital states. Digital states. So red, blue, green, can be all that. All of this data stored against time, that's what a pi tag is. Pi tags also have a few particular attributes of their own that describe the pi tag. One is a name. Every pi tag on a pi server has a name. It's a unique string name, and if you're ever searching for pi tags, often you search for it based on the pi tag name. So there's a tag name. There's also something called a point source, which often refers to where the data is coming from. And there's a few other attributes as well, including a description. So we can have a description for all us humans to know what this tag is what this tag is recording. Description. So what we're really interested in with a pi tag is connecting it to the data. So in our items that we own, we have sensors that are actually recording stuff, like a temperature in a building, or some kind of height sensor for a tank, or some kind of RPM gauge for a pump. And the way this works is that those sensors are sent over to a pi tag, where they enter a pi server and they're stored as a pi tag. And then that pi tag is forwarded on to the pi attribute, so the temperature up here, the RPMs of the pump, the height of the tank, and then that's sent on to the user through PiAF. And the user can do really great things, like, for instance here, he could compare the rotations per minute of the pump over the last 3 months, so maybe the average and maybe the peak running state of the pump, against when it was last maintained. And he couldn't do this before because these are from different systems, and that's difficult because that's in that system and this is in the Pi system, and bringing them together would take a lot of manual collection. And that's what the Pi system excels at, is taking data from anywhere and putting it together and then getting it to anywhere else. And it does that through Pi assets, Pi attributes, and Pi tags. It allows you to scale out your system to a wide degree. Now, once you have this set up, you can go places. Once you have a Pi asset configured and you have attributes configured for it, guess what? You can just copy and paste that asset to create another one. So, say I own 500 pumps. Well, I can create just one pump asset with a set of attributes and a set of Pi tags for it, and then just copy and replicate that Pi asset using something called a template. But we replicate that Pi asset, and now we can make all of our pumps available to all of our users very easily, just like we could with the first one. So that's an overview of the basics of Pi assets, Pi attributes, and Pi tags, and their attributes and what describes them.